Recall from back in Calc 1, we defined the average value from a to b on some closed interval of f of x as being equal to, let's call it f av for notation wise. If my function goes from a to b, then this average, we said, is simply the length of this interval, which is b minus a. So 1 over b minus a times the integral from a to b of f of x dx. So what I'm doing is I'm calculating this total area, and then I'm dividing it by the length of this interval, which is what I'm doing right here. So this was very reasonable for that reason. It's a matter of, like I said, taking that total area and simply dividing it by the length of the interval. Now, the same idea holds true for volumes or for double integrals when working with functions of two variables. The average value of a function for two variables, so let's say functions of two variables, take that idea and say, hey, look, the average is going to be simply equal to 1 over a of r times the double integral over r f of x y dA. And this value a of r, what that represents, this represents the area. I'm going to call it region, although we've only been talking about rectangles. This really works for any region. The area of the region on the xy plane, and I'm going to say under the surface. Oops. Even though that's restricting us to thinking in terms of the surface must be above the xy plane, but we can still find an average even if the surface goes below the xy plane. So this is really the area of the region on the xy plane itself. So if I can try to quickly draw this three-space sort of a thing again. So I'm not really talented when it comes to drawing stuff. Here's my surface, and if I project down onto the xy plane, yeah, that's pretty bad. If this is my surface S, then if I take a look at this area right here, this is on the xy plane. This area is what I'm thinking of as a of r. So the analogy back into Calc 1, I'm going to take the total area under the curve divided by the length of the interval. Here, this double integral, I can think of as a volume. So I'm going to take this volume and divide it by the total area that this surface sits over top of, just like this curve sits over top of this interval. Now, I just said volume, but the same idea holds true even if we can't interpret this as a volume. Because remember, to interpret this as a volume, this surface S really needs to be above the xy plane. But I can still do these integrals and find the average even if my surface dips below the xy plane. We lose that interpretation in terms of volume, but the mathematics is still the same.